Well, hello again everybody, and as you can see we're back in the electronics workshop today and I am surrounded by test gear and equipment. The problem is I've got too much stuff. So I said to my good lady this morning, I really need to have a tidy up, so I'm going to go upstairs to my workshop and I'm going to find all the equipment that I haven't used in some years. I'm going to put it all on one side, I'm going to take it to work or put it into storage or sell it on eBay. I'm going to create some space. Now my partner has me really well worked out. When she knows when I say I'm going to go upstairs and tidy up, she knows how it goes because I've done it too many times before. What actually happens is I come upstairs with the intention of tidying up and then I'll find a piece of test gear and I'll start looking at it and playing with it, and then I'll find another piece of test gear and then I'll go on eBay and buy more test gear. So by the end of the day, there's been no tidying up done. I've got rid of nothing and I've probably bought more. So we're not going to do that today. We're going to be ruthless. We're not going to play with anything. Oh, HP 1652B Logic Analyser. Okay, so as soon as we've given it a wipe, we better just check it still works, haven't we? Oh, personal ThinkJet printer. Yeah, don't think we'll need that because I haven't got one. So this is a Hewlett-Packard 1652B. I always think it's a little bit funny this. I don't know if you can hear it's complaining that it hasn't got a system disk in it. And one of the things that I thought was funny is that the earlier Logic Analysers, for example the HP 1631D, it has firmware built into it, everything's contained on ROM. But even though this machine is a lot later, maybe 10 years, they've gone to these floppy drives. But the device won't actually work unless you put a systems disk in it. And that's probably a little bit of a tip. You can usually score these Logic Analysers quite cheaply on eBay. I think I probably paid about £50 for this. But when I got it, although it came with all the pods and everything you needed and lots of gripper probes, which again are expensive to buy separately, the annoying thing was that the systems disk that came with it was the wrong disk, and so I couldn't use it, and it actually took me quite a while to actually track down some disks for it. So you can see a little test board that I knocked together on a very bored Sunday afternoon, and it doesn't do anything very interesting. In fact, the only thing it does is flash this LED on and off at very precisely once every second. We've got an oven controlled oscillator which has some support circuitry around it just to manage its temperature. We've got a little lamp here which comes on. I can't remember how I designed it. I think the light goes off when the oven is up to temperature because it monitors the current across that's hot. It monitors the current across I think it's that load resistor there, and it notices when the current drops to the heating element in the oven controlled oscillator, that lamp goes off, and then you know that in theory your crystal's up to temperature and locked, whatever. It outputs 10 megahertz onto this green wire, and all we've got here is just an absolute load of decade dividers. So it divides them all down, and what it does is it counts up to 10 million, and then when it gets to 10 million it sends a reset pulse across everything, and we also latch that out and make it flash the LED. So it doesn't do anything interesting at all, but all those delay lines, all those count outputs, we've got output here. And I think the idea that I actually got this for is when I was just playing with some of my Logic Analysers first of all, I just wanted some digital outputs. I just wanted something to connect it to see if it was working. But we're not here to look at that. I'm definitely not going to start playing with that. So I've just connected channel 1 of the oscilloscope here to the output from the crystal. After much fiddling and pressing all the buttons for about half an hour, I discovered that you actually have to press the run button to turn the oscilloscope on. So yeah, silly me. So channel 1 of the oscilloscope works. Does channel 2 work? Yeah. Does. So when you buy a Logic Analyser, hopefully it's going to come with a load of these cables, and these cables, some of them plug into the front or they might plug into the back depending on the design of your analyzer. A lot of the HP ones for some reason plug into the back, and a lot of the one by Tektronix and Fluke, mainly Tektronix I'm thinking of, they tend to connect to the front. But you'll have a few of these ribbon cables, and each of the ribbon cables will be responsible for taking the data from a certain number of digital channels. So this one is it's a 16-way cable, so on this pod 1 it will display 16 digital inputs. So you've got the 16 inputs here, and they're all colour coded, and then on the end of those, on the end of the pod, you've got this collection of wires which are basically just designed to be as annoying as possible and get tangled and everything, and then, you know, the ends fall off them, and yeah, it can be a bit of a nightmare actually. But you can either just push the connector onto the pin header of your circuit board. So it's a good idea when you're designing boards and stuff, put a pin header on it so you can actually make it easy to connect your pod from your Logic Analyser. So you can either use these pushing headers, or you can get something called grabber probes, which are like the little crocodile clips, and what that allows you to do is you can actually clip them onto test points or clip them onto your legs of your ICs. Of course, these were used very much in the day of through-hole components, and yeah, I'm not sure what people do today with surface mount boards. I'm assuming that they use different forms of debugging like JTAG or in serial bus or stuff like that. All a bit new and modern for me. I still use Logic Analysers now and again. So we've got the Logic Analysers sampling those inputs that were connected, and you can see that we've got these little tabs here. Now each one of these little tabs, you can see it says pod 1, 0, pod 1, 1, pod 1, 2. So all these numbers here correspond to those wires that were connected to the header on the board. So you can see that pod 1, 0 is pulsing up and down there. It's yeah, it's going up and down. It's a clock waveform, and hopefully you can see that the next pod along is going up and down a little bit less. Everything's flickering around, isn't it? It's quite hard to see what's happening, but this is really the beauty of a Logic Analyser, in that while it's sampling, it's what it's going to be doing now. It's filling up its memory, and it's rolling over, and it's starting again the way I've got it configured. So what we can do is we can stop that, and once we've stopped it, we can actually inspect things in much more detail to actually see what was really going on. So you can see that basically we've got our input clock at the beginning here, and then that gets divided down, and then it's divided down again, then it's divided again. Oh, and you can see some little rump pulses there, they're interesting. And then it's divided down again, and then it's divided down again. And we've got two channels here that's got nothing on them, that's channels 5 and 6 there. Now those are the connectors that I said had broken off the header, so we couldn't connect them. So there you have a 1652B. Now, is this one a keeper, or should it be resigned to the dungeon? Does it deserve space in the workshop? You know what? I'm not sure. I'm going to think about it. Let's look at another one. Well, this is an older model of Logic Analyser, which is a 1631D. And one of the things that I actually like about this is that it kind of comes on more or less instantly. And the other thing that I actually like about it, I actually think that the green screen, the green phosphor screen, it's got a lot more contrast than the other Logic Analyser as we were looking at. I actually think it's much easier to read. Now, one thing about using this older 1631D unit is that the actual user interface can be really quite sluggish on it, depending on what functions it's carried out. Okay, let's try the digital side. If any of you want to see a bit more of this instrument, I did actually make a complete video on it a while back, because I don't even remember. I couldn't buy any of the proper input probes for this, so we actually had to just make some. So I'm just connecting up our data pod here. I'm actually struggling to remember how to work this Logic Analyser. They're not the type of instrument where you can just switch them on and press a lot of buttons. It tends not to get you very far. I'm afraid that this type of equipment, it's just complicated enough where you do need to start reading the manuals. And I don't mind reading manuals, I quite enjoy reading manuals, but yeah, I've not done that today, so I'm struggling to remember how to use it, because I've not used this machine for, well, I've not used it in anger in probably 10 years, and I don't think I've switched it on for more than a year, so I'm afraid I've forgotten all the quirks. Connected the wrong pod. Ah! I think we need pod 0. Come on, pod 0. Where are you, pod 0? I can't remember. Do you have to enable these channels? Does anybody remember? Look at the display here. What it's showing me here is we've got two pods. We've got pod 0 and pod 1. Now pod 0 we've got connected, so I'm hoping you can see we've got some up and down arrows on there. So what that's telling me is that the inputs here are toggling high and low as the board is counting up. Whereas you look at pod 1, it's got lots of dashes and they're at the bottom of the display rather than being at the top. So that means all those inputs are at 0 volts. And the reason for that is because here's pod 1. So pod 1 isn't connected. So let's go ahead and connect pod 1, and then we'll be able to see the whole 16 channels counting up. Just keep your eye on the screen of the Logic Analyser while we connect these digital inputs up. Okay, so I'm going to connect input 0 of pod 1, input 1 of pod 1, input 2 of pod 1, and I will just keep going now. So hopefully we should be able to see some waveforms now. Now I've got to admit, when I connected this up I thought we'd see a nice smooth count up from you know, dividing down, but it looks as though we've got a couple of other things going on here, and as I say, I don't exactly remember in detail what I wired up on this circuit board. It was just designed to output some logic much like this so I could play with Logic Analysers on it. But what we can do, of course, we can stop that like we did on the other one, and we can also zoom in and out and look at things. So we can display this data in a few different ways. At the moment that's a waveform diagram, but we can also see it as a listing. And it's displaying that in hex down here at the moment. I don't really like hex, let's just switch that into binary. You can tell by looking at that we've got some form of binary count, but it looks as though it's not quite right. Maybe I've got some of the probes connected to the wrong lines, most likely. Well, I've been going backwards and forwards between the 31D and the 52B, which is what I've got here, and I think I've made a decision that I'm going to keep hold of the 52B. It's just that little bit easier to use. The operator's interface is less prone to kind of freezing and getting tied up. It's just obviously a more modern machine. I'm not exactly sure how much difference there is in terms of performance between the two machines, but just the fact that this is more modern, I'm guessing that it's going to be the better performer. The thing about Logic Analysers, it's all about depth of the memory, and I'm just guessing that in the 10 years between these two machines there's probably considerably more memory installed in here than there was on the 31D, but maybe I'll have a look at the specification. But this machine's a bit lighter, it's a bit more portable. The things like having a scroll wheel means it is easier to actually select between the menus. Thinkjet printer, anyone? Now, I seem to think many moons ago I did actually make a video about using this protocol analyzer. I don't think it's the kind of equipment I'm going to use in the near future. It's a very specialist piece of kit. I don't really want it taking up room in the workshop, so I'm going to be hard, and this is going to be resigned to my deep dark stores at work. So yeah, bye bye. Well, we seem to be making some progress. I can almost see the top of the bench now. Well, I'm sure you all remember that back in the day I made a video on this 881 Powerscope. So unfortunately it does seem to have developed a little bit of a fault, and you can kind of see what's happening there. I haven't got a circuit diagram for this Powerscope. I haven't been able to find one, and it's gone completely there. But yeah, that needs repairing. It was working one day and then it wasn't, and we're going to have a look at it in the future. Now, I've just noticed as I pick this scope up and turn it over, it's emitting a really horrible burning smell, so obviously something has let the magic smoke out inside there. Shame we haven't got smell-o-vision here, because God, this thing stinks to high heaven. It smells like power supply smoke to me. Be careful, I don't really want to touch anything that might be live in here. Come on, get out. Now, considering how much this stinks, I would have thought there would be some very obvious burnt components, but you know, or a trail of smoke. But I'm not seeing anything. Oh, look at all this conventional logic in here. It's all IC socketed as well. And I'm also seeing quite a few tantalum capacitors, so they're always nasty, aren't they? So probably the best thing to do is disconnect all the board and then check the power rails, rather than doing what I'm doing, which is switch on and see what burns. So I reckon that it's probably something to do with the time base or the sweep controls that have gone wrong. maybe they've got no power going to them at all, but I don't have a circuit diagram for this scope, and I'm not going to play about with it for now. I was just hoping that whatever was smoking and giving off that horrible smell would continue to smoke off and give a horrible smell off. Whatever's burnt out seems to have burnt out. I think it's quite interesting that all the ICs in this scope are all socketed. Everyone's in a socket, and I'm never sure whether that's a sign of a piece of equipment being good or just that they had so many problems that they decided to put all the ICs in sockets to make them easier to repair. Well, somehow it's got a bit of a Heath Robinson look about it, this scope. I suspect it wasn't something that was made in particularly high volumes. I think the smell's coming from the back end, from the power supply section. Yeah, I don't know, it's just got a really pungent, acrid smell. So something's died in the back. So I think we've got a repair there in the future, haven't we? But for now, I want it out the workshop to create a bit of space. So yeah, you're going. So you can see the 4-channel differential inputs there, and I've got to admit that really is quite a thing of beauty. Now, I'm not going to pretend I know what all that gubbins does in there, but yeah, it's all doing something. You know, I didn't want to get into this today, but I feel as though I should just pull this back cover off to see if I can see the power supply, because I can't see anything. There's a board up there, but I can't see it. I think the smell's coming from up there, but it's hard to tell. It drifts around. Given the amount of smoke or how badly it smells in this room now, it's not me farting for once. I definitely thought we were going to find something pretty nasty and burnt and charred, and yeah, I'm not finding anything. Kind of wondering if it could be. There's a strong smell around here. I think this is the high voltage transformer, but if that had failed, you know, gone dead, we wouldn't have the very bright CRT. So I don't think that's died, but. The same for the you know, the switching transistors that are actually switching it on and off. We still had a trace, so yeah, we've got HT, haven't we? So this is an RF signal generator that I've had for many years, and it's pretty unique. And I've actually got the operating and service manual for it. It says operating, it seems to be mainly a service manual. And the manual that comes with this is absolutely beautiful. It has every component and every circuit diagram you could possibly need. It's really well put together. So I don't really know anything about Sister and Donna. It has got a tab on the back that says Fawn EMI, so I don't know if it was part of the Fawn EMI group. I'm not sure. Maybe some of you test equipment finiciados can tell me something about Sister and Donna. I think it's probably American made because, well, certainly this manual is printed in America, so that's where I'm guessing it's come from. Physically, it looks to be about, I don't know, 19-inch rack kind of size, but the amazing thing about it, this thing weighs an absolute ton. It is really, really heavy. That's one of the interesting things about it. But the other interesting things about it is that I haven't found a signal generator in terms of output level that is as accurate as this is. I mean, normally you get a little bit of variance between one signal generator and another and various bits of test gear. But to the best of my test equipment's ability, whatever you set these outputs to, it's exactly what you get. The other thing I like about this signal generator is it's just very easy to use. So you can have a frequency modulated output, you can have CW, which is just a carrier wave, or you can have amplitude modulation. It's got internal and external modulation, so you can select that there. And I think you can also select things like modulation depth. Like a lot of my things, it's been a while since I've operated it, so I can't remember exactly how it works. The other thing about it is it's got a very well protected RF output. So if you are stupid enough to connect something into it, you shouldn't. What happens is, I did do it once. I managed to put some DC onto the front of it with a piece of faulty equipment. Basically, I think that little light comes on, you hear something click, and it says overload, and you've got to take the overload off it, press that, and it resets, and off you go again. And it is really well protected. To set the frequency on this, you can set it in 100 Hz steps, and it's kind of almost mechanical in its nature. So basically, it's got these little clicky wheels. So I think that would be 900 megahertz there. So I think it goes to like 999 megahertz. Now, I don't have an awful lot to say about this signal generator. It is a frequency synthesized type. and the actual clock is derived from an oven controlled oscillator. It does appear to have all the options fitted, which I think is the eye stability oscillator, and it's also got a GPIB interface. Not that I've ever used it, but it's got one on the back. So I just flick the thumb wheel switch up one, it's going to be at 2 meg, and the next thumb wheel along here, we'll just flick that up, and that's going to be now 12, and if I flick it up again, this far one, it's going to be 112. And okay, just for shits and giggles, let's take the frequency up a bit. So we're at 300 megs at the moment, 400, 500, 600, 700, 800, and let's stop at 900. Now these two knobs here control the output. So basically this one is the output level, so that's kind of like the course control. So this is set to 0, that's a calibrated position for it, if you like. And then at this side we've got it set to the 0 dBm position. So again, if you look at our output, it's not set up dead on this, but it's hovering around -1 dBm, so that output's pretty good. If we actually just turn the attenuator up, we'll see this drop by 20 dBm, so that's then going to drop from being that to about -20, so let's put -20 dBm attenuation, so there you go, -40, -60, and then we're going to be dropping right down into the noise there. I'm not certain, but I think I may have been slightly overloading the front end of the spectrum analyzer when I first plugged this in. So I've just put some attenuation in now, so we're running at -20 dBm. So there's 100 megs, 200, 300, 400, 500, 600, 700, 800, 900, let's try 990. There's 990. That's 999. Well, almost. Well, I'm afraid as much as I like this signal generator, you take up too much room and you're too heavy. Well, I've spotted something else lurking under the bench. So this is a Ballantine programmable amplitude test set. And I've got to admit, I've never used this before, never used it. Oh, probably helps if I do I have to put that to plus? Let me set it to 10 kilohertz. Right, nothing's happening. Why isn't anything happening? Let's try the deviation off. You can really tell I don't know what I'm doing here, can't you? Well, I've been fiddling with this now for about 10 minutes and I don't seem to have been getting anywhere, but I have just noticed that there's got this light switched on here which says remote next to it. And yeah, why would it be in remote? I've got no idea. I thought there might be a dip switch on the back to actually select remote, but you can get some markers out of it, so it seems to be doing the markers. There's another output socket here which is it says amplitude and line frequency. So this socket here just seems to be appearing to put out a reduced whatever your line voltage is, it puts it out at 1 volt peak to peak for some reason. Just thought it was worth checking this BNC connection because it does look a little bit dirty and maybe damaged inside. I don't think it is that, but let's just double check because that's an easy thing to check. I'm afraid I can't get anything out of it, absolutely not a sausage. The way I'm guessing it works is you've got this kind of primary setting here that you set the output level to, so at the moment that's set to 10 volts and it's on ×1 down here, so 1 times 10 is 10. So I'm guessing we should get 10 volts output out of this socket here, or you could times it to ×2 and that would be 20, 30, 40, 50, 60, etc. So you could get up to 100 volts out here, so you could get a bit of a shock off that. And then you've got this output mode switch here, and it looks as though that the output mode switch goes between setting an output voltage of say -10 volts, you can have ground, so again that'll be 0 volts, won't it? Or you can have +10 volts, and again I'm guessing +10 volts means you get 10 volts out of this socket here. And then you've got a timing mode, so it's got 10 kilohertz, 1 kilohertz, 100 hertz or 10 hertz. And again, we've tried all them, and yeah, absolutely not a sausage. So I actually think that when somebody gave this to me, I'm sure I plugged it in and tried it, and it was all working, and it's just been sat under my bench for about a year since somebody gave it to me. So maybe this is going to have to be a future repair video. Probably shouldn't miss this opportunity to clean something, seeing as that was the whole idea of today. Wow, this is one heavy thing. Okay, so we've gone ahead and I've connected the pods up to the counter circuit, and we're using, I don't know, we're using about 24 bits there. And one thing you can see, we've got a bit of a rat's nest, and that's again just another thing that makes these pieces of equipment quite hard and sometimes tedious to use. You've got to go ahead and connect all these data grabbers to various points in your circuit. It's not so bad if, like me, you've got some dedicated test points or you designed a header to connect to, but back in the day you had to actually clip on top of the ICs, or in many cases you had to if you were working on a board that didn't have these, didn't have a header you could plug into. This is kind of like obsolete knowledge, but if you were designing a board, a modern board, and you want to maybe debug it with a Logic Analyser, it really is a good idea to design some kind of breakout connector on it so you can get access to all the data pins you might want to look at. Maybe when you've developed the board you can take it off and throw it away, but it's a really good development tool to actually have a header with a breakout on it. So now we've got everything set up, let's have a look at some waveforms. Waveform, there we go. Okay, so I've actually got the machine running at the moment, so it's just repetitively sampling, and you can see that we've got the first 7 bits of information displayed. But what we can actually do is I can use a scroll wheel on the machine, and we can actually look at more bits of the let's call it the data bus if we so desire, and that's okay, that's quite useful. But often for things like this, it's often easier to actually look at the binary, especially if you're trying to look for something specific. And I've actually got a trigger word set up on here, which is just basically zeros. So I'm looking for the counter rolling over. So let me just choose to have a look at that listing. Okay, so again we can see the binary bits here. So you can see all these zeros here. These are just pod inputs that aren't connected, and then all these bits here that you can see have got ones or zeros on there. They're connected at the moment. So you can see the least significant bit here. That's going 1 0 1 0 1 0. And then the next bit along is going 1 1 0 0 1 1 0 0, and then the next bit along is going 1 1 1 0 0 0 1 1 1. So basically a classic binary counter. And again, that's all very nice, but if like me you don't work in software these days, it can be a little bit annoying trying to convert binary into decimal. So this machine will do it for you. So let's just put it into decimal, and of course now we're viewing it in decimal. So I said that I set a trigger word of 000, which is the first point of data there where you got the number 1 against it. But what this will actually do is it also pre-fills. It's like a pre-trigger on an oscilloscope, so you can actually see the history before the trigger point, and that's quite important for something like a counter, because you want to see the point at which it rolled over. And I don't know if I'm reading that right, I can't be bothered to count the zeros, but to me that looks like we count up to 10 million, and then it rolls over from 10 million to 0 0 0, and then it starts counting again 1 2 3 4 5 6 7 8. Anyway, I found that quite interesting, but unfortunately it's not really getting my room tidied, is it? So yeah, nose to the grindstone, back to it. And just entering full-on scrounging mode, if anybody's got a PS2 mouse or some feet, the ones that kind of plug into the 3 slots on the bottom of HP gear, if you could hook me up with that, I would be much appreciated, because I need those. Thanks. Oh, that looks as though it could do with a bit of a tidy, doesn't it? So what this is, it's an absorption watt meter, and it's made by Ray Caldana, and what is it? Oh yeah, 1 megahertz to 1 gigahertz. And I used to use this all the time. It was probably one of my most used bits of test gear at one point, and that's before the days that I was rich enough to own these communications analyzers and things like that. So this was actually a really good little bit of kit, and it was useful that it had the 10 watt range and the 30 watt range, and yeah, I probably used to use this almost every day. Very, very, very accurate, very reliable. And I can't even remember where I picked this up again. I've had it years. It's a 150 watt dummy load. What does it? Has it got a frequency bandwidth on it? No. Oh, this will be good for a few hundred megahertz, I would have thought. At least it looks as though it's come from maybe the mobile phone industry, so yeah, it's probably up in the gigahertz actually. And it's got the big warning labels on, like a lot of RF equipment. It says do not dismantle toxic material, and there's another warning label on the back with a little skull and crossbones there, because these things contain something called beryllium oxide, and I don't know a huge amount about it, but you know, back in the day you would see a lot of RF test gear and it would have these warnings on it, and anything that had this beryllium oxide in it, I think it's maybe some form of insulator, but apparently it's very, very toxic. So it's got this little skull and crossbones on the back. Okay, we've got a couple of attenuators here, RF attenuators. What have we got? We've got, oh, it's 50 ohms of course, because most of the radio stuff I would do would be 50 ohms, and it's a 20 dB attenuator, and then we've also got a 10 dB attenuator bolted on the front of it. Now, I used to use spectrum analysers all the time, and for anybody who uses spectrum analysers, it's always a really good idea to have some attenuators on the front of it. Pretty much my spectrum analysers nearly always permanently live with one of these attenuator pads bolted to them. Couple of things that they do. One, it will just offer the input of your Logic Analyser potentially a little bit more protection in case you do something stupid. And if you're using something shit like a Rigol spectrum analyzer, you will find that the tracking generators are absolutely awful, not flat at all, and the impedance varies along with the frequency sweep. So it's always a really good idea to have I don't know, a 10 dB pad on the output from your tracking generator, because it will just flatten everything out a little bit more. This is some form of stub. So this is a little RF filter. Don't know what I made up this for, it's probably been in the drawer for years. It says it's tuned to 145.365, and I'm guessing I was using that to I don't know, to get a bit more dynamic range out of something. I was trying to knock out a fundamental so I could look at a harmonic or something. Probably made it to do a particular job. Bit of a whip aerial. Got a few of these. Strange little, I don't know, it's metric or imperial, don't know where that came from. Directional couplers. Again, any of you that are interested in RF test gear, and again, really these types of equipment go very much for your spectrum analysers. You cannot be without a directional coupler. They will do a few things, a directional coupler. One thing you can do with it, if you've got something like well, actually it doesn't have to be a Rigol, any spectral analyzer will do it that's got a tracking generator. What you can do these is you can work out things like RF return loss with them if you've got a directional coupler like this. And the other thing you can do with it is if you're actually want to connect quite a high power transmitter, you must never connect a transmitter to the input of your spectrum analyzer, because you will blow it up in short order. You must never do that. In fact, I don't like connecting transmitters to my spectrum analyzers, and it's best avoided. But if you are going to do it, what you can do is you can use a directional coupler, and I think this one has got, I think I've written it on the side of it, minus 30 dB coupling. So basically what you will do is you will put your analyzer, in fact I've labelled it up so I don't make mistakes. You connect your dummy load to one of the ports here. So for example, this dummy load will be connected to that port there. You connect this end to your transmitter. This end, I think you just put a terminating plug, if I remember right. I can't remember what you put in there, I think you have to blank it off. And then you get either the forward or the return power coming out. I think one of these ports gives you forward power, the other one gives its return. So yeah, very useful bit of kit, directional couplers. You can do lots with them, you can analyse antennas with them, and you can protect the front end of your spectrum analyzer. Okay, we've got another directional coupler here. I seem to think that this is something that I was using for some gigahertz work that I was doing. I think this one only goes up to about 30 megs, but I think this one goes up into the gigahertz. No, it doesn't. Yeah, it does 32 megs, but I think this goes into like 1.2 gigs or something. So it's another coupler. Oh, an Aritsu preamplifier module. Oh, I think I was using this again. I was doing some pre-compliance testing where I was looking at some very low levels, and the front end on my rather cheap and nasty and ancient spectrum analysers weren't quite cutting it. So I needed a bit of amplification. So here we've got an Aritsu preamplifier, which goes from 9 kHz to 2.2 GHz with a 20 dB gain. Lovely. Just trying to think what this is. Off the top of my head, I think this is a dead bug style pulse generator. It's one of the sorts of things that you can use for working out the bandwidth of your oscilloscope. You can basically, it'll just output a square wave that's got a very fast rising edge, and then you can look at the rise time and do a little calculation, and it'll tell you what the bandwidth for your scope is. So I think that's what that is. Can't quite remember. Again, it's been rattling about in that drawer for years. Oh right, I have just remembered now. Yeah, I remembered what I was using this for. I was using it to try and find a fault in a length of coax cable. So what you can do is you can actually you can send a pulse down an RF coax, and if you've got a break in the cable or it's damaged, you've got a non-perfect impedance, and what you'll do is you'll get a reflection. So what you can do is you can use your oscilloscope to you can look at the rising edge of this pulse, and then you can look for the reflection coming back down the coax, and then you can just work out, you know, if you know the dielectric constant of the coax, dielectric constant, velocity factor. If you know what the velocity factor is, you can work out where the fault is in your coax, because the time between the pulse going out and being reflected back, that's proportionate to the length of coax where the fault is located. So that's what that was for. It was a pulse generator where we were trying to find some damage to a coax. It really pains me that I can't get the wife to run a dishcloth around the workshop. I've tried encouraging her with violence, but it doesn't seem to do the trick. Well, I moved everything out the workshop and had it all nice and tidy-ish, but unfortunately it's all come back again because apparently it was leaving dents in the carpet. Can't win.